looking at if we have a probability distribution, finding the mean and standard deviation of a probability distribution. So we looked at this example yesterday. So how many were there again? We had this filled out in your notes. Is this in your notes? One was at 20. Yeah, it was 10 over 20, 5 over 20, 3 over 20, 1 over 20, 1 over 20. And we found our average to be, I think, was it 7.25? Okay, so we did that yesterday by typing them into L1, L2, doing one variable stats. Okay, we're going to have to continue with that today, so we want to make sure we understand how we did that yesterday. Overall, we okay?
Yeah.
Okay. So then we said, so on average, when you play this game, you win $7.25. So then we asked the question, would you pay $5 to play this game? So we went back and changed our expected values, and we found that our average was 2.25. So on average, when you play this game, you are going to win $2.25. Yes. Oh, okay. Okay. Thought you were raising your hand. Okay. Now, we're going to talk. All we're going to do today is we're going to look at a whole bunch of examples of this type of thing, and so we want to create our probability distribution. So as we do these, here's a thought I want you to have in your head. When you would play this game, if you would pay $5 to play, what happens when you play that? So here's what I mean. If you pay $5 to play and you draw a $1, what happened? You lost 4, right? So what you're going to think about as we do this, because this is the one part people get confused about, how does it change from what you started with to what you ended up with? So for example, on the 100, if you pay $5 and they give you 100, and you pull 100, excuse me, what's different from where you started? This is going to be 95. And we want to make that clear because this is not I win 100. It's 95 because it's the difference from where you started. So if I bet $5 and then they give me 100 back, how much did I win? 95, not 100, because you had to pay 5. Does that make sense? And that's going to be the one part we can get confused about. And we want to try to keep that clear just so we're all kind of on the same page as we go through. So, with that said, let's look at a couple more examples. And this is pretty much all we're doing today is figuring out expected values. All right. So let's look at this example. If a player rolls 2 dice and gets the sum of 2 and 12, they win $20. If they get a 7, they win 5. If the cost to play the game is $3, find the expectation. Find the expected value of the game. We're going to do the second part with the fundraiser later. So how do we do this? What we need to consider is our probability distribution. So the first thing you want to do on all of these is you want to consider what are the possible random variables. So remember, the random variables have to be a number. It's got to be a numerical value that can be an outcome of this game. So with the 3 things that can happen, what are the numerical things that could happen in this game? It's not win-lose. So if you pay $3 and you don't roll a 2, 12, or 7, what happens? You lose $3. So that's -3. if they roll a 2 or a 12, they win 20. So we want to be clear, and this kind of problem is what we're doing right now. I will try to make it either clear. Do we want to say win 20? We can do this either way. Do we want to say win 20 as you get your money back and 20? Or they give you 20 and so you actually only increase 17? 17? Okay. We can do it either way. And I try to be very clear on tests and quizzes about this stuff because sometimes it's not clear, and I'll explain more as we keep going here today. So the other time is you can win 5, which would be winning 2 because you pay 3. Okay. So now the next thing we have to do, we got to figure out our probabilities of these things occurring. This is where what we did in the last chapter comes in, because you got to figure out probabilities like we did in the last chapter. So what is the probability of rolling a 2 or a 12? So how do you get a 2? 1, 1. How do you get a 12? 6 and 6. And you could use our whole addition problem and say you add them, or you could just think about that's going to be what? 2 out of 36. And that is when we win 20. Now, I am not going to simplify it on purpose. So what is the probability you get a 7? We need to write that down and think about it. How can you get a 7? You could get a, okay, now you could get 3 or 4. Let me give you a hint as you do these problems. Have some pattern to what you do. Don't just write down random things, because then it's easy to miss them. So what I mean by that is I'm going to go 2, 6, or 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, 6, 1. So I'm kind of writing them in order. So there are how many ways? 6. So that is 6 out of 36. And this is why I didn't simplify, because if it's a probability distribution, what do they all have to add up to? 1. So if I have 8 out of 36, losing is going to be 28 out of 36. So find the expected value on your calculator. And there is more than one way to do that. So I'll let you try it, and then we'll talk about how you did it and how you figured it out. Does anybody need a calculator or not have a calculator? Do you have a calculator, or do you need one?
This one's dead.
Yeah, some of those, not all of those work. So if you need one, you can go over and grab one. For those of you that weren't here yesterday, Casey and Trey, the best way to do this is type your X's into L1 and your probabilities into L2. That's step 1. And then I will explain what the second step would be.